In this unit, we are reviewing the prerequisite skills that you will need to be successful in AP Calculus. In this video, we will review some fundamental algebra skills. For this first exercise, we are given several statements. We have to decide if they are true or false. If they are false, we need to correct the underlined part to make it true. So for part A, we know that when you have a power raised to a power, you do multiply. So x to the 12th power is true. This is correct. How about part B? When you are multiplying two variables, you add the exponents. That's not going to make 3 over 2. So let's come off to the side here. So we need to add 1/2 plus 3 over 1. But this would be the same as 1/2 plus 6 over 2. So this would be the same as x to the 7 halves power. Now we've made it true. All right, how about part C? Well, this is definitely false. They are illustrating a common mistake. A lot of students think that when you square a binomial, you can just square each part separately. You can't do that. Focus, people. Get your head in the game. So what you have to do is multiply this out. So we have to do x plus 3 times x plus 3. So you can FOIL this or double distribute, however you want to think about it. But we should end up with x squared plus 6x plus 9. So now it's true. How about part D? Here is another common bad algebra mistake. Many students think that, hey, we can just cancel these ones out and then x will go into x squared and that's going to leave x. No, no, no. You have subtraction here. You can't cancel things out that are connected by addition or subtraction. Please do not do that nonsense. Instead, you need to factor the numerator. So let's just continue this over here. So x squared minus 1, that's the difference of two squares. So this would be x plus 1 times x minus 1. In the denominator, we have the x minus 1, and then these will cancel each other out. So the result should be x plus 1. So I'll just squeeze this in right here. Now it is true. Okay, how about part E? Let's see what is happening. We have this entire expression being squared. So I'm going to duplicate this over here. So the binomial is squared. But we do have a GCF of 4 inside of here. So if I factor that 4 outside of parentheses, I will have x plus 3 inside of here. This is all being squared. Now, it is valid to go ahead and now square each of these factors. If I square 4, I'm going to get 16. Of course, if I square x plus 3, I will have x plus 3 squared. So that means this statement is true. All right, and how about part F here? So they're illustrating a common mistake that students will make, thinking that you can add the 3 plus 2 and make 5. No, 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 no. Well, guys, would you add, if I said 3 plus, let's say 2x, is this going to make 5x? Hopefully you're looking at this and you're thinking, well, of course not. This would only happen if we had 3x plus 2x. That would give you 5x. So they have to be like terms in order to add. So this radical, like when you see the 2 radical x minus 3, this is just like the x I was just showing you. So for this to work out, we need like terms. For example, we need 3 radical x minus 3 plus 2 radical x minus 3. Now these are like terms. Now you could put them together and make 5 radical x minus 3. So this is the change that you have to make to the underlined part in order to make this true. Section A2, let's do some more algebra. Part A, if 6 is a 0 of function f, let's stop right there. If 6 is a 0 of f, that means if you plug in 6, you should get 0. So as soon as I see 6 is a 0 of f, I translate that into f at 6 equals 0. Then blank is a solution to f at 2x equals 0. Let me copy this down side by side. So now we're saying f at 2x is equal to 0. Compare what's inside of function f in both cases. F at 6 equals 0, f at 2x equals 0. Based on this, we can conclude that 2x must equal 6. And if 2x is equal to 6, then of course x is equal to 3 as I divide both sides by 2. So that is the answer to part A. For part B, Lucy has the equation 2 times the quantity 4x plus 6 squared minus 8 equals 16. She multiplies both sides by 1/2. If she does this correctly, what is the resulting equation? Well, multiplying both sides of the equation by 1/2 is the same as dividing both sides of the equation by 2. So the key is when you divide by 2, you're going to have to divide each term by 2. So this equation is really separated into 3 terms, and we need to remember to divide all 3 terms by 2. So I'm going to divide by 2 here, here, and here. I know it's a little bit hard to see. But these 2's are going to cancel each other out. And then I'm left with, I'll write it over here. I'm left with 4x plus 6 squared. Nothing happened to the stuff inside, all right? The 2 I divided by just cancels out the 2 in front. And then this minus 8 divided by 2 gives us negative 4. And 16 divided by 2 is 8. So this should be your resulting equation. Part C, we need to simplify this. A concept that will come up very frequently, I think of as a plus b divided by c. You can separate this into 2 separate fractions. This would be the same as a plus c. This would be the same as a over c plus b over c. So you can use division to separate this into 2 separate fractions. So definitely get comfortable with that. Applying that to this fraction, can you see that this will be the same as 2 divided by 2 plus or minus 4 radical 10 over 2. Now we can easily simplify this. 2 divided by 2 is 1, plus or minus, and then 4 divided by 2 is 2. So that's the answer. Very often in calculus, you will have to rationalize the denominator. So a key to rationalizing the denominator and getting rid of the radical that's in the denominator is the concept of a conjugate. So remember, if I have a binomial a plus b, the conjugate of this is going to be a minus b. Now you could sit here and FOIL this out, but I really want you to memorize that the result that you get when you multiply a binomial and its conjugate will always be a squared minus b squared. The middle term automatically will cancel out every single time. So let's see how that helps us rationalize the denominator. The denominator is 3 plus radical x minus 1. This is like my a plus b. So I need to multiply by the conjugate. So I need to multiply by a minus b. That's 3 minus radical x minus 1. And we have to do the same thing in the numerator, so we aren't actually changing the value of the expression. We are really multiplying by 1. But I don't want you to have to sit here and think through this step by step. 3 times 3 is 9, blah. I don't want you to do that. I want you to use the pattern that when you multiply by the conjugate, the result will always be a squared minus b squared. So what's a squared and what's b squared? Well, a is 3, so my a squared is 9. So a squared minus, now b squared. b is the square root of x minus 1. So b squared, if you square a radical, the radical just goes away. So I will end up with x minus 1. You have to put it in parentheses because of the minus sign. It needs to be distributed. But just remember, we're just doing a squared minus b squared here. Square this, you get 9. Square this, the radical goes away. Meanwhile, let's leave the numerator the way it is for now. So we will have 12 times 3 minus radical x minus 1. We have to distribute this minus sign in the denominator. So we will have 9 minus x plus 1. And I'm just going to leave this numerator the same for now. So the following could be our final answer. 12 times 3 minus the square root of x minus 1 over, this will be 10 minus x. So usually we will just leave the answer like this. There's nothing wrong with distributing the 12, it's just not necessary. But if you did distribute that 12, you would get 36 minus 12 radical x minus 1 over your 10 minus x. Part E, if f of x equals 3x squared plus x plus 5, then what about the expression f at x plus h minus f of x? So let's just do this one part at a time. F of x plus h means take x plus h and substitute it in for all of the x's. So that would be like this. So I see 3x squared. So I'm going to put 3 parentheses squared plus parentheses plus 5. So this is function f, but I'm just ready to substitute in whatever I need. But I'm supposed to have f at x plus h. So that's why I'm going to put x plus h where all the x's were. Okay, so this is f at x plus h. Next, we need minus f of x. Well, f of x is just the original function. So minus f of x would be like this. Minus, well, the only thing is I really need to put this in parentheses because I have multiple terms, and when you have a minus sign like this, it needs to be distributed. So I need to say parentheses 3x squared plus x plus 5. So here, this purple part is f at x plus h, where I substituted x plus h, and then minus plain old f of x, only in parentheses. So we just need to simplify this all down. Let's start with the x plus h squared part. So I need to do that. So I think I'll just show this a little bit separately temporarily. if I have x plus h squared, I've already demonstrated earlier in this video, this will be the same thing as having x plus h times x plus h, which is going to give you x squared plus, well, inner I have hx, and outer I have another hx. So this is plus 2hx, and then plus h squared. So this is what I get just from this portion right here. So let me copy that down. Don't forget I have a 3 out in the front of all of this. So I have 3 times all of this. X squared plus 2hx plus h squared. Alright, so I've done that. Next I have my plus x plus h. It's not being squared or anything, so I'm just going to leave it outside of parentheses now. So plus x plus h. And then I have my plus 5 right there. So now it's time for this blue part. I'm just going to distribute the minus sign. So this is going to give me minus 3x squared minus x minus 5. Minus x minus 5. Now I need to distribute the 3. But I do not feel like copying this entire thing over again just to distribute the 3. So I think I'll pause and just do that real quick in this same space. Distributing the 3 gave me this part right here. Now the parentheses are all gone, so I can scan through looking for like terms to combine. I'm noticing that I have a 3x squared right here, and then I have a minus 3x squared. So those are going to cancel each other out completely. Is there anything else like that? Well, let's see. I've got plus x right here, and I have a minus x right here. So those are gone. What else do you see? I've got a plus 5 right here and a minus 5 right here. So everything I just highlighted is gone. So I'm just going to recopy the unhighlighted part off to the side. So that'll be 6hx plus 3h squared plus h. So that is the final simplified answer. Part F, a cone's volume is given by v equals 1/3 pi r squared h. But if r is equal to 3h, write v in terms of h only. So we want to rewrite this formula in terms of h by substituting r with 3h. So the original formula is volume is equal to 1/3 pi, and then we have r squared, but I'm going to do a substitution. So instead of writing r, I'm going to put parentheses squared h. So this is the volume formula, but with parentheses where the r used to be. Now we can do this substitution. Instead of r, I'm going to put 3h. So right now, really, we have the volume formula written in terms of h only. So maybe this is one form of the answer. But I think they want us to go ahead and simplify this down as much as we can. So this will lead to the following. We have volume is equal to 1/3 pi. Squaring 3h. We can just square each of these factors. So this will give us 9 because you square the 3. And then h squared. But then we have the h that's on the outside. So of course this will simplify more because we have h squared times h. Together this is h to the 3rd power. So I think this is setting up our final answer. So volume is equal to 1/3 pi. Well, no, this won't be the final answer. So we have 9 h to the 3rd power. So actually, let me backtrack a tiny bit. So the reason why that wouldn't have been the final answer is because I see we've got the 3 and the 9 right here. These will simplify. This is like having 9 over 1. 3 goes into 9 3 times. So when I simplify this part of it, I'm going to end up with 3 pi. And then we have h squared times h, which is h to the 3rd power. So this will be the final simplified answer. To do part G, we first need a little mini lesson on special triangles. So remember, when you have a 30, 60, 90 triangle, across from the large angle, you're going to have the long leg. Across from the smaller angle, you will have the short leg. And of course, across from the 90-degree angle, you have the hypotenuse. But it is all about the short leg right here. Let's make up a number and say that the short leg was 7. Given the short leg, we can easily find the hypotenuse and the long leg. The hypotenuse is always double the short leg, so this would be 14. The long leg is always the short leg times radical 3. This is a shortcut. If you ever forget this, you can always use the Pythagorean theorem, but it's easier if you remember this pattern. Now, I'm going to just put a variable here. So if the short leg was n, remember for the hypotenuse, you double this. So the hypotenuse would be 2n, and then we multiply by radical 3 to get the long leg. So we would have n radical 3. So this is the shortcut I need you to keep in the back of your mind. Part G says an equilateral triangle has side length s. Write an expression for its area in terms of s. So let's draw an equilateral triangle. Okay, so equilateral triangle, all 3 sides are equal. We are told that the side length is s. So this is s, and this is s, and this is s. You'll see why I'm leaving space in a minute. We aren't given any other numbers, and we are asked to find the area of this triangle, or an expression for it. We need to get some numbers from somewhere, so how about this? We know that the sum of all of the angles in a triangle is 180. So we have 3 angles that are equal, because this is an equilateral triangle. So if we divide by 3, that will give us the measure of each angle. Of course, 180 divided by 3 is 60. So each of these angles is 60. But we are supposed to come up with an expression for the area of this triangle. The formula for the area of a triangle is 1/2 base times height. Well, we have the base, that's s, but we don't have the height. If we're going to come up with an expression for the area, we are going to need an expression for this height. Remember, this angle at the top was a total of 60. So by dropping this height, we have split it up into 30 and 30. So maybe now you can see why we did this little mini lesson on the 30, 60, 90 triangle. If you take an equilateral triangle and you create the height, you have 2 30, 60, 90 triangles. Let's just focus on the right half of the triangle. Notice that since the entire bottom of the equilateral triangle was s, then the right half should be 1/2 s. But what about the height? Here's where our knowledge of 30, 60, 90 triangles comes in. If the short leg is n, then we can get the long leg by doing n times radical 3. So the short leg is 1/2 s. To get the long leg, which is the height, I need to multiply this by radical 3. But imagine that if I multiply this by radical 3 right now, this is like radical 3 over 1. this will end up as radical 3 over 2s. So that's what the height is going to be. So my height is radical 3 over 2s. Now we are ready to start writing the expression for the area of the equilateral triangle. Remember, we're talking about the area of the whole triangle, not just the right-hand side. So the area is 1/2 base times height. So this is going to be 1/2. The base of the triangle is s. And then the height is this radical 3 over 2s. So I have radical 3 over 2s. All we have to do is simplify this. Well, I'm seeing 1/2 times radical 3 over 2. Just focus on these two expressions. We can multiply those together. That will give us radical 3 over 4. So now the area is equal to radical 3 over 4. And then that leaves us with s times s, which of course will be s squared. So this should be the final answer.